In the previous video, we looked at how to complete the square. And in this video, we're going to look to see how we can use completing the square as a means of extracting information about a quadratic function quickly and easily. So, if you think of a quadratic function when you have completed the square, this is the kind of thing that you can expect to see. Now, if we try and think about when the function is going to take its lowest value, the function is going to take its lowest value when what's in that red box is at its smallest. Now, how small can something squared possibly get? And you know it can't get any smaller than 0. So the lowest value happens when what's in the red box is 0, and what value of x gives you the red box value of 0? It has to be an x value of 3, because 3 minus 3 would be 0. Now, if the red box was 0, that would mean that our function would have a value of 1. Okay, that would be the lowest it could go. So this function, as you know, is going to be u-shaped because x squared is positive, and the turning point is going to be 3, 1, because it can't get any lower than 1, and that value of 1 takes place when x is 3. Okay, let's have a look at the next one. Again, this function will take its value, its lowest value, when what's in the red box is 0. What value of x gives you a red box value of 0? And you've guessed it, it is when x is 5, because 5 minus 5 would give you 0. 0 squared is 0. So this function doesn't get any lower than -3, because the lowest the function can be is -3, because what's in the red box can't get any smaller than 0. So this function takes a minimum value of -3, and that occurs when x is 5. So the turning point is 5, -3. And for this last one here, again, if we just put a box around our bracket, the lowest that can get is 0, and when does that become 0? That becomes 0 when x is -3, because when you replace x with -3, -3 plus 3 is 0, 0 squared is 0, and the function cannot get any lower than 0 plus 9, which is 9. So the lowest value this function is going to take is 9, and that will occur when x is -3. So these are our turning points for these three functions. Now, all of these functions were u-shaped parabolas because x squared is positive. So what we're talking about is each function having a minimum turning point. Okay, now if we consider these functions, we've got a negative in front of the bracket each time. So that tells you when you were to multiply all of this out that x squared would be negative, which tells you that each of our parabolas are n-shaped. That means our turning point is a maximum turning point. Now, so we want to think about when the maximum turning point occurs. Now, again, the maximum turning point will occur when the function is at its maximum. And the function will be at its maximum when whatever it is you are taking away will be at its minimum. Okay, the less you take away, the bigger it is at the end of the day. So, when is what's in the red box at its minimum? Well, it's at its minimum when what's in the bracket is 0, because 0 squared is the smallest you can get, anything squared can get is 0. Okay, so how low can this function go? Or how high can this function go, I should say. And this function is at its highest when what's in the red box is at its lowest. So what value of x would give me 0 inside my bracket? And that is a value of 9, because 9 minus 9 is 0. So this function never gets any higher than 2. That's the highest it can be. It's as high as it can be, because something is at its greatest when whatever it is you're taking away is at its least. Okay? And when does this maximum value of 2 occur? It occurs when x is 9. So our turning point is 9, 2. Again, if we go on to this one, this function will be at its greatest when whatever it is you're taking away is going to be at its minimum. How small can that get? Anything squared can't get smaller than 0. What value of x would give me 0 in here? Because 0 squared is 0, x would have to be 2. So our function never gets any greater than negative 4. And that value of negative 4 occurs when x is 2. So our turning point is 2, negative 4. Let's do another one. This function here, negative x plus 5 in brackets all squared plus 1, is going to be at its maximum when the thing that's getting taken away is at its minimum. How small can that possibly get? And it can't get any smaller than 0. What value of x gives me a red box value of 0? It is a value of x being negative 5, because negative 5 plus 5 is 0. So when that is 0, the function takes a value of 1. So that is the highest it can get. This function never gets any bigger than 1, and that value occurs when x is negative 5. So if you look at the functions and the turning points, you should be able to see that when you have a function which has, in this case, p and q in these positions, the turning point, the x value, is just the opposite of what you see in here. Okay, so it's negative p, and the y value of the turning point is just the number that's tagging along on the outside. Okay, so your turning point is easily readable once you have completed the square. You just look at the value that is within the bracket, look at the value which is outside the bracket, and you derive it from these values. It's dead easy. Okay, so let's think about what we need to make up a sketch. Now, as we said, completing the square is done for a reason, and one of the reasons that it's used is to just identify key features of a quadratic function quickly. Now, if you were asked to do a sketch, there are certain things that you should think about. Now, the first of these is you've got to identify and include the turning point. You've also got to think about the axis of symmetry. Now, the axis of symmetry, that will go through the turning point. It will be a vertical line going through the turning point. So the equation will be x equals something. Remember, a parabola, which is what you get when you graph a quadratic function, it's symmetrical. You also want to include maybe the y-intercept. Now, the y-intercept will occur when x is 0, and you've got to also think about the shape. Remember, if x squared is positive, it's going to be u-shaped. If x squared is negative, it's going to be n-shaped. Okay, so let's look at this quadratic function here, and let's see if we can pick out these key features and then do a quick sketch. Okay, so our shape, first of all, when I multiply this out, x squared is positive, so we're talking of a u-shaped parabola. The turning point is going to be negative 3, negative 4. Our axis of symmetry has to go through this point. It's a vertical line, so the equation is x equals negative 3. And the y-intercept occurs when x is 0. So that's going to be y equals 0 plus 3 all squared, so 3 squared, and then we're taking away 4. 9 minus 4 is 5. So the coordinates of the y-intercept are 0, 5. Okay, and if you want to do a sketch, all you have to do is draw your x-axis, your y-axis, draw your key points. So we've got a turning point at negative 3, negative 4, so we'll just say that that's there. Our y-intercept is 0, 5, so we'll say that that is there. We can do a sketch which doesn't have to be a work of art, but just has to show the shape and go through the turning point and our y-intercept. And we also should include our axis of symmetry. And if I draw a vertical line up there, we'll say that the equation of the axis of symmetry is x equals negative 3. And that's all there is to it. Okay, that is how you can use completing the square to as a means of identifying key features, which you can then use to sketch a quadratic function. Let's have a look at this one. Okay, now this time, again, it's x squared is going to be positive, so it's that shape. Your turning point is going to be taken from these values, so it's 6, 1. Your axis of symmetry, it goes through the turning point, so it's x equals 6. And the y-intercept occurs when x is 0, so it's going to be 0, negative 6, which is negative 6, all squared plus 1, so that gives you 37. Okay, so your turning point, your y-intercept, sorry, is going to be 0, 37. So let's throw all of that onto our set of axes. Okay, now our turning point, first of all, is 6, 1. So we'll mark that there. Our y-intercept is 0, 37. Now it doesn't have to be in proportion, it doesn't have to be a perfect work of art, as I said, as long as the points are all aligned properly and in relation to one another. So we've got our shape, got our turning point, got our y-intercept. We can include the axis of symmetry, and that is going to be a vertical line, which will have an equation of x equals 6. Okay. Try this one. Let's have a look. This time our shape is going to be n-shaped, because when you multiply all of this out, x squared would be negative. So it's a maximum turning point we're going to have. What would that turning point be? Read the values. Negative 6, 2. The axis of symmetry, vertical straight line going through the turning point, so x equals negative 6. And the y-intercept is going to occur when x is 0. Now that's going to be negative 0 plus 6 all squared plus 2. So that means negative, and this is going to be 36, and we're adding 2, so negative 34. So it's going to be 0, negative 34. So let's draw our set of axes, and let's see how we get on. Now, negative 6, 2 is going to be, let's say, there. Okay. Now, our y-intercept is 0, negative 34. So I'm just going to mark that on and say that that's where that is. Now, you know that it's n-shaped, so your points are all lining up nicely. So we can then just come down like so, and we can add our axis of symmetry, and we can write that its equation would be x equals negative 6. Okay, so these are the kind of key features you want to include when you have completed the square, or these are the kind of key things you can quickly pick up about a quadratic function. So see if you can do these two yourselves, okay? See if you can identify the key features of each quadratic function and then produce a sketch. So you can pause the video and check back in a wee while and see if you've done it all correctly. Okay, let's have a look at this first question. Okay, so we get rid of that. We'll do the first question just now. Shape. Okay, so we've got a U-shaped parabola. The turning point would be negative 7, negative 2. Axis of symmetry, x equals negative 7. And the y-intercept is going to be y equals 0 plus 7 is 7. 7 squared, 49, minus 2, so 47. So you have a y-intercept of 0, 47. Let's sketch what we know. So throw our x-axis, throw our y-axis. Turning point negative 7, negative 2, so it's going to be there. Our y-intercept is going to be there. So 0, 47, we will mark on our coordinates, negative 7, negative 2, and we can then finish it off and draw our parabola, and we can draw on our axis of symmetry. And the axis of symmetry would have an equation of x equals negative 7. Okay, so that's the first one. A U-shaped parabola is what we would get. Now this one, when you would multiply everything out here, you're going to get negative x squared. So that means your shape is going to be n-shaped. So your turning point is a maximum turning point, and it's going to occur when x is 5 and when y is 6. The axis of symmetry is going to be when x equals 5, And your y-intercept is going to happen when y is negative. Now 0 minus 5 is negative 5. You square that, and you then add 6. Just be careful when you're subbing in 0 for x, especially when you've got a negative outside the bracket. So that gives you negative 25 plus 6, which is going to be negative 19. So your y-intercept is going to be 0, negative 19. Let's quickly sketch our function. What have we got? We've got a turning point of 5, 6, which we can say is there. Our y-intercept is 0, negative 19. So let's write that on. And then it's n-shaped, so our points all look pretty good. And we can draw on our axis of symmetry, which will be a straight line going vertically down like so, and it will have an equation of x equals 5. Okay, so that's how you would use a function where you've completed the square to quickly identify key features such as the turning point, the axis of symmetry, the y-intercept, and so on. Now there's one more question I want us to have a wee look at, okay? And it's a wee bit different to what we've done. So you're told that a function has an equation in the form where you've completed the square. Y equals x plus a all squared plus b. You're told it intersects the x-axis at the points 3, 0 and 11, 0. So this here must be 3, 0, and this here must be 11, 0. Okay? What is the equation of the axis of symmetry, first of all? Now, you know when you graph a quadratic function, you end up with a parabola, and whether it's n-shaped or u-shaped, it's always symmetrical. So what I want you to think about is the distance from here to here. Now, you're going from 3 to 11, so that's a distance of 8. Okay? Now, half of that is going to be the distance from, let's say, if I use a different color, from there to there. So the pink line is a distance of 8, the green line is a distance of 4. So we want to find the halfway point, and the halfway point would be 7. So if you think about it, all you have to do is just take 3 and 11, add them up together, you get 14, and half of 14 is 7. So you know that halfway between 3 and 11, is 7. So the equation of the axis of symmetry is just going to be x equals 7. Okay, that's the answer to the first bit. Okay, we're then asked to find the value of a. Now, what is a? If we go back and look at the question, a is the value that is within the bracket. Now, if our turning point, is on the axis of symmetry, we know the turning point is going to have an x value of 7. So it's going to be 7 something. Now, if 7 is the x value, what goes in here is going to be negative 7. Okay, the value of a is going to be negative 7, because negative 7 is going to partner with 7 to give you a 0 value in here, which will then give you the minimum value of the whole quadratic function, which is what occurs at the turning point. You're then asked to find b. Okay, now we know that a is negative 7. Okay, so we know that y is equal to x minus 7 all squared plus b. And you're asked to find b. Now, how are we going to do that? Well, if we go back to the question, we know that the point 3, 0 and 11, 0 have to be on the function, on the parabola. So we know that 3, 0 and 11, 0 satisfy this equation. So it doesn't matter which one you use as such. I'm just going to use 11, 0. So I'm going to say that when y is 0, that x is 11, and I'm going to take it from there. Now 11 minus 7 is 4, so 0, we'll say, is equal to 4 squared plus b. So 0 is 16 plus b, so b is negative 16. So we weren't asked to do this, but if we were, we would have to say that y equals x minus 7 all squared minus 16. So that is the equation of our quadratic function. Okay, that's the equation of our quadratic function there. Now the last thing you're asked is to find the coordinates of the y-intercept. Now you know the y-intercept occurs when x is 0. So we can start off by saying, well, our answer is going to be 0 something. So what value of y partners with an x value of 0? Well, we just go and use this. And we say y equals, and instead of x, we'll replace x with a 0. Negative 7 squared is 49. 49 minus 16 is going to be 33. So our y-intercept is going to be 0, 33. Okay, so that is how you can use your knowledge of how the turning point mirrors the values of completing of a function where you've completed the square to answer some questions and deal with some problems at this level. So I hope that you found that helpful, and I hope you can now see why completing the square is such a handy technique to know. Okay.